Okay, so let's solve another problem. So, bali dito sa problem is meron tayong tatlong steel rod. So, bali meron tayong EB, EC, and ED. Ito yung tatlong steel rod natin, no? So, meron silang cross-sectional area na 250 square mm. Lahat sila, no? Okay. So, they are jointly support the 7.5 kilonewton na load dito as shown dito sa figure at point A, no? So, assuming that there was no slack or stress in the rods before the load was applied. Okay, so bali walang ibang stress, no? So, bali yung stress na mangyayari dito is yung paglagay na ng 7.5 kilonewton. So, find the force in each rod. Use elastic modulus for steel na 200 gigapascal, which is constant, no, for steel. So, the dimension for steel rod EC is 2.75 meter. Okay, so yung tinatanong is ano daw yung mga forces na mag-act dito sa mga steel rod natin. So, bali, kunin ko lang to. So, solve natin yan. So, first is gawa tayo ng equilibrium equation, no? So, makikita natin dito, if isolate natin yung joint A, so may mga forces tayo dito, no? So, anyway, the best assumption is assume tension. So, meron tayo ditong force for bar EB. And then, we have force for rod EC. And then, we have force for rod ED, no? So, meron tayong mga angle. Okay? So, bali, based dito sa figure na ganito. So, like, ito yung Cartesian natin. Ito yung point A. So, may mga forces tayo na mag-act, no? So, i-separate ko na lang. So, meron tayo ditong downward force na 7.5 kilonewton. Meron tayo ditong mga inclined load and vertical load. This is force ni EB at angle 25 degrees. Ito yung force ni EC. And ito yung force ni ED at angle 25 degrees. Ngayon, kung gagawa tayo ng equation dito, equilibrium equation. So, bali meron tayong summation of forces x equal to 0. So, assume na lang natin na positive yung going sa ganitong direction, no? So, bali meron tayong force ED sine 25, and then itong force EB which is going to the negative x direction. So, this is force AB sine 25 degrees. So, this must be equal to 0. So, bali dito, meron tayong force ED na sine 25, which is equivalent to force AB na sine 25. Parang, tinranspose ko lang, no? So, cancel out yung sine 25. So, yung force ED pala is equivalent to force AB. Okay? So, sabihin natin this is our equation 1. Ngayon, another equilibrium equation na pwede natin magawa dito is itong summation of forces vertical, na. So, let's assume na yung going up is positive. So, bali, meron tayong force EB cosine 25. And then, meron tayong going up na force EC. And meron tayong going up na force AD, and that is cosine 25. Meron tayong going down na 7.5 kilonewton. So, sabihin natin this is 7,500 Newton. So, this must be equal to 0. So, bali dito, meron na tayong equation na force AB cosine 25 plus force AC plus force AD cosine 25 is equivalent to 7,500. Sabihin natin this is our equation 2. Okay. So, meron tayong 2 equation, no? And nakikita natin meron tayong 3 unknowns. So, we need 3 equation, 3 unknowns, no? To solve the unknowns. Diba? So, ngayon, wala tayong magawang equilibrium equation. So, hindi talaga siya kaya ng equilibrium equation. So, this is a statically indeterminate structure, no? So, ngayon, this is strength of material. So, hihingi tayo ng tulong ni deformation. Okay? Ngayon, sa deformation na part, and deformation equation, no? Hihingi tayo. So, ngayon, kunin natin ito ulit. Bali, ito yun, no? Ito yung structure natin. And then, sabihin natin, change ko muna yung kulay, ha? Ayan, no? So, sa deformation equation is, tanggalin ko muna to. So, ayan, no? So, dito, makikita natin na since may naghihila tayo dito at point A, hinihila natin yan eh. So, yung tendency is magdi-deflect to, no? Yung bar EC. So, bale, magdi-deflect to. Sabihin natin ito yung deflection nung sabihin natin ito yung deformation nung bar EC. This is point A. And then, sabihin natin, kasi may naghihila tayo, no? So, yung deformation nung EB is ganito, no? And then, yung deformation ni bar ED is ganyan, no? So, we know yung angle dito by vertical angle theorem. So, this must also be 25 degrees. And this one must also be 25 degrees. So, bale, makakuha tayo ng equation out of this one, no? So, meron tayo ditong 90 degrees. And then, this one is 90 degrees. And so, bale yung dito na part, ito yung deflection of bar AB. Yung ito naman, ito yung deflection nung bar ED. And yung ito naman, ito yung deflection nung bar EC. Okay? So, out of this one, so makikita natin, if we want to compute for cosine theta, we know this is 90 degrees. And so by cosine 25 degrees, so that is sa SOHCAHTOA, di ba? So we have the adjacent, which is the deflection of bar ED all over yung hypotenuse niya, no? Which is yung deflection ng bar AC. So, dito yan apart, no? Yung ito. Okay? Sabihin natin. Ito yan apart. Kulayan natin. Ito. Okay? So, sa kabilang side naman, ganun pa rin, no? Yung cosine 25. So, this is 90 degrees. So, that is adjacent deflection of bar AB over yung hypotenuse, which is itong deformation ng bar EC, no? Okay? So, mas higher yung length nung nung deformation ng bar EC kasi inline siya sa direction ng load, no? So, probably siya yung pinaka-stress na part, no? Unlike dito sa bar AB, which is naka-component pa siya, no? So, mas maliit yung force na humihila sa kanila. Okay, so bali ito yung magiging deformation equation natin. So, bali, makikita natin dito na yung deformation ng bar AD is equivalent lang ng cosine 25 deformation of bar EC. Okay? So, bali, yung sa AB naman, we have deformation of bar AB is also cosine 25 of deformation ni bar EC. So, sabihin natin, kunin ko yung ito na part, no? Yung ito. So, we know deformation is pullovers are everywhere. So, we have force ni EB, length ni EB, all over, area ni EB, elastic modulus ni bar AB. And then, dito naman, we have force ni EC, length ni EC, all over, area ni EC, and elastic modulus ni EC cosine 25. Okay, so since the same yung area nung lahat ng steel rod, so cancel out yung area, no? Tsaka yung elastic modulus, since lahat to steel, so cancel out yung elastic modulus ng steel. So bali yung matitira na lang dito sa equation is we have force ni AB, length ni AB is equivalent ni force ni EC, length ni EC cosine 25. So, kukunin na lang natin yung length ni AB, which is ito yan. So, ito yung length ni AB, no? We know this is 90 degrees. We have 25. So, by cosine 25 degrees. So, we know yung length nito is given. So that is 2.75 meters. No? So this is 2.75 meters. So yan yung magiging adjacent. And then yung hypotenuse is itong length ng AB. So thus yung length ni AB is 2.75 over cosine 25. So, length ni AB is equivalent to 3.034. Okay? Okay, so force AB is equivalent to length ni EC over length ni AB cosine 25, and then we have force ni EC. So, we just need to substitute yung length ni EC, which is 2.75. Yung length ni EB is 3.034. So, multiply it by cosine 25. Ayan. So, we have force ni EC. So, yung force ni EB ngayon is, if we calculate that one using our calculator, so we have 2.75 over 3.034. Oops. And then cosine 25. So yung sagot niyan is 0.821. Force ni EC. So for dito naman na part, yan. So the same, no? Kasi yung length ni EB, yung ito. Yan. So, yung length ni AD is also equivalent sa length ni AB. So, pareho lang, no? So, bali yung force AD din is equivalent to 0.821 force EC. Okay? Okay, so So, bali dito sa equation 2, kunin ko ito yung equation 2. Copy. So, from equation 2, so ito na yan, ha? Ito na yan. Ngayon, i-substitute natin yung value ni force EB. So, we have force EB na, sabihin natin this is equation 3. So, substitute equation 3, we have 0.821 ni force ni EC cosine 25. And then, we have force ni AC. And then, yung force ni AD, substitute natin yung, sabihin natin this is equation 4. So, 0.821 force ni AC cosine 25. This is equivalent to 7,500. So, ngayon, masosolve natin yung value ng force ni AC using our calculator. So, that is equivalent to 3014 Newton, or this is 3.014 kilonewton. And ito na yung sagot. And for force EB naman, di ba? From equation 1, yung ito. Pero yung dalawa, no? Copy. From equation 1, ito yan. Ayan. So, makikita natin na isa lang. So, force ED, which is equivalent to force EB, which is also obvious, no? Which is yun dito. Pero yung dalawa sa equation 3 and 4, pareho sila. 0.821 ni force AC. So, substitute natin 0.821 multiplied by 3.014. So, therefore, yung sagot nito is 2.47 kilonewton. And ito na yung sagot. Okay, so I think that's it, no? I think yun lang. So, if we want to compute for the deformation nung tatlong steel rod, so anyway, given na yung lahat ng forces, no? We have tatlong forces. We just need to substitute yung value nung dito, no? Yan. Yung force, yung length, yung area, tsaka yung E. For instance, no? If you want to compute for, yung problem doesn't, hindi naman hinanap to sa problem. No? Pero sabihin natin, hanapin natin yung deformation. So, yung isa lang, no? Sabihin natin yung deformation ng bar EC. So, yung gagawin lang natin is we have this force EC, length ng EC, cross-sectional area ng EC, tsaka yung elastic modulus ng EC. So, yung force ng EC, we have 3014 Newton multiplied by yung length ni EC. Diba ito yun? Length ni EC is 2.75 meters. So, this is 2750 mm. Yung cross-sectional area is 250. And then yung elastic modulus is 200 gigapascal. So, 200 times 10 to the power of 3. So, if we compute this one, so yung magiging sagot nito is 0.166 mm. So, ito na yung deformation. So, bale yung magiging total length nung nung bar EC is we have this original length plus yung deflection nung EC. So yung original length nung bar EC is 2.75 meters. So this is 2.75 plus 0.166 all over 1,000, no? Para ito naka-meters. So kung makikita mo, sobrang liit ng value. So 2.75 plus, kasi kalahin mo yung 0.0166 mm. So sobrang liit, no? Pero makikita natin sa deflection natin is exaggerated siya, no? Just for the sake na makompute natin. Okay? 166 all over 1,000. So we have 2.75.0166 meters. So yan yung magiging total length na nung bar. Okay? So I think that's it, no? So see you sa next na video. Thank you.